So what value will you actually be getting from this session? What I hope, at least, what you will be getting. So I hope that you will be inspired, maybe learn something new, and get to know cool CNCF projects. Since this is Rancher and CNCF and Kubernetes meetup, some of the things that I talk about might not be as new to you guys as to some other places where I've talked. But I still hope you get some inspiration and new ideas maybe for your work or life in general. So there was a wonderful introduction to me already, but just as a quick recap. So hi, my name is Annie. I've been building tech and startup communities for multiple years now. I am the Kubernetes and CNCF meetup co-organizer with Lucas here as well. I have been coaching startups for many years as well, and I do have a podcast called Cloud Gossip. More on that later. I am affiliated with Microsoft since my day job is there, but I am representing myself and the love of community here today. So to kick things off, so this mysterious CNCF, Cloud Native Computing Foundation, which might be more familiar to some of you, less familiar to some, but just as a recap, let's go through what is it, what does it mean in this in the context of this talk as well. So the purpose really is to build sustainable ecosystems for cloud native software. So what it actually means is that it brings together world's top developers and users and vendors and runs the largest open source developer conferences such as KubeCon and whatnot. So CNCF is part of the Linux Foundation as well. So, and I think everyone in this meetup probably understands the impact of cloud native and Kubernetes and containers in general. But I think it can't kind of ever be understated how much of an importance and how much of an impact they have, and why this talk or any cloud native or CNCF talk is very relevant and very of today in a way. And there is some data here from the most recent CNCF survey, from 2020 survey, about how the use of containers in production has really increased in the last years, as well as year and year. And I highly do recommend checking out the CNCF surveys as well. They are very informative. I was just going through today once again and I'm always surprised how I always notice something new and interesting in there. So really cool stuff. So what does actually CNCF or the cloud native landscape look like, or what does it kind of mean if you're unfamiliar? Well, this is how it looks like. And just from this slide, you will get the idea that it is very complicated, very large, very kind of monolith-like in a way. So there is so many different corners of it. You could probably talk just about CNCF of different parts of it for multiple hours. But this talk will be particularly focusing on projects from CNCF as well. So let's take a look at more of a smaller view of the landscape. So there are 3 stages of CNCF projects. So they start from sandbox, then go to incubating, and then go to graduated. So what this means that if a new project gets initiated to the CNCF ecosystem, they start from the sandbox phase, then move to incubating, and then the graduated. The numbers there represent approximately how many projects are in each of the phases. So there's 44 in sandbox, 23 in incubating, and 14 in graduated. And just as a contrast, when I started doing this kind of talks a few years ago, then it was only few projects in graduated. So it takes quite a long time to actually go through all of the phases. And to kind of further understand what does it actually mean to be in these different phases. It means that the sandbox projects, they are really like kind of the innovators, the techies, the early adopters, and from the incubating it starts to go further from there. It's the early majority and whatnot. And for the graduated projects, they are very large, very big. They are fully recommended for production and whatnot. So they're really something that you can utilize in all aspects as well. So there are a few projects in this session that I will be going through. And just as a disclaimer, this is not a scientific selection method that I've done, nor am I a fortune teller, definitely not a fortune teller. So expectation management wise, I definitely do not know what will succeed or fail, but these are just projects that I hear people talking about, what I'm excited about. So just quick disclaimer there. And as another expectation management, usually CNCF intro talks in, for example, KubeCon are around 30 to 45 minutes. And this is a 20 to 25 minute talk covering 4 projects instead of 1 project per 30 to 45 minutes. So don't expect, super deep dive in this super quick talk. But I will provide links in the end if you want to deep dive more into any of the projects as well. And then the projects that I will be going through are Helm, Linkery, Kudos, and Kera. I would have a Helm demo as well, but since we are doing a shorter version, we're going to focus on the Linkery demo today, and then have Helm, Kudos, and Kera as more of an overview, an introductory level there as well. So let's get into the projects themselves. Helm, I think, should be maybe familiar to most people, at least in the CNCF and Kubernetes ecosystem. It's a package manager for Kubernetes, and it is the best way to find, share, and use software built for Kubernetes. I have done a talk a few years ago when Helm was a lot smaller on the Kubernetes meetup as well. So I don't know if anyone might have been there to hear that one as well. So as said, it's a package manager. It's similar to Homebrew, Snap, or Chocolatey for Kubernetes. And I really kind of think that one of the Helm maintainers put it really nicely. What does package management in the context of Helm and in general mean? So it really is tooling that enables someone who has knowledge of an application to package it up in a way that someone else who has neither extensive knowledge of the application or the way it needs to be run in platform, so that they can actually use it as well. So it really is the power of package management there, and therefore the power of Helm as well. So Helm is really nice. It can help you manage complexity, charts describe even the most complex apps, provide repeatable application installation, and serve as a single point of authority. It has really easy updates. It takes the pain out of updates as well. It has really simple sharing. Charts are easy to version, share, and host. And it has really good rollback, so you can roll back to an older version of a release with ease with Helm. So what are kind of like the principles behind Helm? So Helm takes security very seriously, and Helm is very much a large project nowadays. So it has multiple maintainers, multiple companies behind it. It has all the characteristics of like a longer term project with power user email list, release candidates. It supports Mac, Linux, Windows, and already in 2019 it had passed 1 million downloads a month. So it is a graduated project, as you might be able to tell from all the data here. So Helm is used using charts, and the prerequisites really are just to have a Kubernetes cluster and deciding if any security configurations that you want to apply, and then installing and configuring Helm obviously as well. And such as a super small bonus project here is Artifact Hub. So it's a CNCF sandbox project. With it, you can really find Helm charts easily, and you can find and install and publish Kubernetes packages. So Helm used to have its own like Helm Hub, but now it has been kind of consolidated in a way that it serves all the CNCF projects. And Artifact Hub really makes discovering artifacts to use with CNCF projects an ease, unlike it used to be a lot more difficult as well. So I would have a demo on how to deploy WordPress super easily, but since I think Helm is very familiar, hopefully, to a lot of people here, I will be skipping that and going straight to Linkery. So here is the page of Linkery. So Linkery is an incubating project at CNCF. It is a service mesh. It really is ultralight, ultra fast, and security first mesh for Kubernetes. It is incredibly community-minded. I really like the approach that the maintainers have as far as that goes. It's very welcoming as well. It's the first service mesh. Istio might be nowadays, but it has few percentage more users than others, but it is similar to Istio, but it's the first one. So the overall goal is of Linkery is to reduce mental overhead of having a service mesh. So what does it actually do? It does observability, so service level important metrics such as success rates, latency, ZTC, and reliability, retries, timeouts, and as well as security. So what are the benefits of Linkerd then? Really, as I mentioned before, the thriving open source community is very nice and really cool. It is 100% Apache licensed. It is an incredibly fast, growing and active, friendly community. It has a really good, simple, minimalist design. So it's no complex APIs or configuration needed. It has deep runtime diagnostics. You can really get a comprehensive suite of diagnostic tools, and including automatic service dependency maps and live traffic samples. It's ultra light and ultra fast, as mentioned before. It's built in Rust, and the data plane proxies are incredibly small and blazing fast. Installs in seconds with zero configuration as well. And it has actionable service metric as well, such as success rate, request volume, and latency as well. So what are kind of like the Linkerd principles? I kind of like the approach. It has a really nice just works mentality. So it's essentially very bare minimum comparing to other service meshes, but it just works in its ultra light and simple, reduce operational complexity way. It's very security first. It's security's default, not an extra. It has its own custom proxy, unlike a lot of other CNCF projects might use Envoy, which is another CNCF project, but it has its own proxy called Linkerd 2, which makes it foundation for being ultralight and other parts of it as well. So the Linkerd demo app that I will be showing today, here is the architecture essentially. So it's a proper enterprise-grade app in a way. And it's just, has Linkerd on it to show you the actionable metrics as well. So what is actually needed to use Linkerd? Just using this, that's it. That's how easy it is. So it's very, very easy to approach as well. So then let's do a quick Linkerd demo. Let's do it. So if we go here, I have color-coded my terminal because it's crazy without it, and do kubectl here. We get the port forwarded there, so we actually get the emoji vote app that I have open here as well working. So here we can vote for our. Oh yeah, this is actually the one that's goes to the wrong one, but we can actually go here, pick this one and view the leaderboard, vote on your favorite. Whatnot. It's just a very standard kind of emoji voting app. Nothing super different there. So then if we go, I have to copy paste everything because if I don't, I will mess up a typo for sure. Then let's do this one here. So if we do this here, we see we can see the bots voting there on the background in here. And then if we go for another one right here, then we see what's happening in a single bot there. And then if we want to see, the actual graphical interface more, we go here, and it will open up here. So in here we see a bit more, maybe easier for the eyes version here. We can click on here and we see this that I showed you before as well. And that's very nice. And if we want to see like a graphical version here, we can go here, start from there as well. We see the same data that I've shown before as well. And if we go to here and then we click on here, we can actually see it in Prometheus as well, which is in my opinion really cool. And you can see that it's super easy to use as well. So then let's get back to the slide deck as well. Let's kick this off here. So moving on to the next project, and I think we're doing okay on time as well. So CUDA, the Kubernetes Universal Declarative Operator. So what is CUDA actually? It really kind of boils down to the stateless versus stateful app conversation in a way. If all apps were stateless, everything would be really simple, but not all apps are stateless. Stateful apps really need logic, a specific knowledge to run a certain application. Kafka might be different from Cassandra, etc. And Kubernetes has been very focused on stateless, and stateful apps in general might not like it as much. So there is obviously Kubernetes has created stateful sets to combat this issue, but it doesn't kind of solve all of the fundamental issues. And operators are used to solve this issue. So operators manages and monitors the lifecycle, but it takes a lot of custom knowledge to build them, and really a lot of custom work, a lot of resources, a lot of work, because each operator is unique and purpose-built for each application. And often operator framework or kube builder is used there. But it requires a lot of deep expertise, and may require thousands of lines of code. So substantial engineering resource is needed. So the solution here is Kudos, so Kubernetes Universal Declarative Operator there. And rather than using a custom operator, Kudos provides a universal operator with concept of plans inbuilt. So what are the benefits of Kudos? It can create operators without needing deep knowledge of Kubernetes or coding by just defining the lifecycle stages. It just has a lot easier to use because it has Kubernetes APIs. It has Kubernetes native management as well, aka using kubectl and other familiar tools. So really nice and easy to use there. It is a sandbox project as well. And then to the second sandbox project, in addition to the bonus project Artifact Hub in the talk, so KEDA, which is Kubernetes event-driven autoscaling. So what is KEDA? It really is built on the idea of serverless, just to get you kind of focus on your code, event-driven code and scaling, and on-demand compute and pay-per-use as well. So it is essentially default Kubernetes scaling is not really well suited for event-driven applications, and Kubernetes is more for research-based scaling in general, and event-driven scaling controlling can then provide that it can run inside any Kubernetes cluster. It can monitor the rate of events to preemptively act before CPU is affected, and then you can install it into new or existing clusters. And it is just event-driven scale controlling that can, run inside Kubernetes clusters, and it has extensible and pluggable scalars to grab metrics from multiple sources as well. So kind of what is then KEDA built on? It's not rebuilding anything that Kubernetes offers out of the box. That's one of the principles there. It's single purpose, simple, non-intrusive, works with any container and any workload there as well. So then kind of wrapping up, what did we go through in this very quick kind of overview on mini projects and Cncf in general as well. We went through a Cncf overview, just mentioned. We went through Helm, Linkery, and Linkery Demo. Then we went through Kudos and KEDA, plus the bonus project of Artifact Hub. And as promised, here is some learn more links and resources. There's a few, but I think the most important link in this page would be the links and slides in the end. So if you want to check out all of these links, my slides will be in there, in GitHub there. So then you can get there, and then you can also get the links from there. But as mentioned, I really highly recommend the Cncf survey, really highly interesting, all the project sites, and particularly if you like any of the projects that you're using them in your day-to-day life, then I really highly support supporting your favorite projects in GitHub as well. And I really, in general, for example, Cncf YouTube has really good resources, as well as another YouTube channel called Tech World with Nana, with really good resources on cloud native as well. And just kind of like a last plug, not because it's necessarily my podcast in a way, but because I think the episode we did with Tom Kirkhope, the maintainer of Kata, was very interesting to hear from the perspective of maintainer as well. What does it mean to maintain an open source project with Cncf? Yeah.
Thanks, Annie. We have a question for you on the chat from Yamal.
Yeah.
Asking, is Kudos similar to Cuba Builder?
Yeah, well, in the sense that, as I said, you can use Kube Builder to build the operators, but Kudo has then like more, you don't have to custom build it from there. So it is similar area, but not exactly the same.
All right, so it's more like a complement.